one of these days I'm going to forget, I think, to record. Then I'll count on you to remind me. But usually you guys are pretty good about that. Good morning. Here we are. What is it? Tuesday? Crazy. All right. I just remembered that you guys submitted your Markdown practice documents. So I'm just going to run through. I haven't done it yet because I forgot. But if you submitted an HTML file, you're going to get that mark. So there's no feedback that you're waiting on or anything. But I'll flip through those and give you those marks. So that's a good start, right? So I made a note because I had forgotten to do that. Okay, so as a quick review from last day, right? We talked about variables, right? So variables are the columns of a spreadsheet. That's not, you know, the definition, but that's the easiest way to think about them. Right, so you've got a spreadsheet and you've got the columns in the spreadsheet. And then, so what we said was, okay, we're going to need to classify these variables, right? And so what we landed on last day, and we talked about some other stuff too, but I guess just one variable. A variable is either going to be numerical or categorical. Okay. We can split them up even further. I'll put it on here, but for most cases, the key difference is it numerical or is it categorical, right? So is it a measurement or is it categories? Okay. For numerical data, the check-in point that I use is, does it make sense to talk about the average of that variable, right? So it makes sense to talk about the average height. It makes sense to talk about the average speed, the average age, the average income, right? So it makes sense to talk about all those averages. It doesn't make sense to talk about things like the average hair color or the average degree, right, that you're doing. So that's kind of the check-in point, right? You have to ask yourself, for numerical data, does it make sense to talk about the average? If yes, then it is a numerical variable. Yeah. Categorical data is a little bit easier to identify, I find, because it'll be these distinct categories. Okay. We did take it a little bit further. It's not super important to know the further classifications, but a numerical variable can be split into either discrete or continuous. Okay. Most of our analyses stay the same regardless, so I'm not going to talk about it any further, but kind of 1, 2, 3, right? Those would be discrete data points. So age would be discrete, right? So age, for example, whereas a continuous variable, it really just depends on your device that you're measuring with, and you could potentially have an even more precise measurement than you got if you just had a better device, right? Because what we know about the line, continuous line, is that we can go an infinite number of steps in, or an infinite number of decimal places in, right? And so for continuous data, things like speed, height, things like that, right? So it's on a continuous scale. Categorical data, I think the easiest way to think about it is, do I have these categories, right? And then we can split it up even further and we can talk about ordinal categorical data. So is there some natural ordering? Or if there isn't, then you have nominal data, right? And that's when you have no natural ordering, but you do have these categories, right? And so here, you can have ordinal or nominal data. So ordinal has natural ordering. No natural order. And it doesn't matter which one you have. Again, the techniques that we use for categorical data stay the same, right? In terms of reporting, if there is some natural order, for example, if you're analyzing survey data, right, on strongly disagree to strongly agree, right? You don't want to report those out of order, right? You always want to keep that order of strongly disagree, disagree, neutral, agree, strongly agree, or potentially the other way around, depending on the results that you're looking for or what you want to guard against, which we'll talk about later today for kind of setting up and collecting data. So if there is some order, it's more about how we report the data, right? And it doesn't really affect our actual analyses and what we do, right? So that's kind of where we ended off last day. And then I think I might have said, okay, now you look at those variables and you try to figure out what type of variable each of them are. Before we do that, I want to introduce one new concept, and then we'll go through and work through the variables and classify the variables. So it's kind of end of the review here. So I had a closer look because, of course, I'm like, I've used Open Intro so much before, they can't possibly have made that many changes. So feeling pretty full of myself, I guess. But then when I looked through it, what I like is that the breakup is actually how I usually break it up. So I usually do chapter 1, part 1, and chapter 1, part 2. But they went ahead and split it into chapter 1 and chapter 2. So I like that. So I think for next day, I'm going to start just following the textbook more closely, because I really like the changes that they made, right? And it is a free textbook, so that's what I like the most, because then everyone can have it and read ahead and have fun, right? So, all right. So kind of new today here. I'll bring in this whole blurb. I even restarted my iPad yesterday, but it's being slow for some reason, and I don't know why. I closed all my windows. It's like an old person. Had a ton of windows open. Oh well. But I closed them all. I restarted and it's still kind of slow. I don't know. Anyways. Okay. So a variable, okay, besides being numerical and ordinal, can either be a response variable or an explanatory variable. Okay. And so what it's going to be based off of is if we have a research question, which we always will have a research question, right? The variable that we're interested in, right? So that main variable that we're concerned with is going to be the response variable. Hey, done your breakfast? Everyone's like, okay, time to wake up. Okay, so if we have a research question, then the response variable is going to be the main variable that we're interested in, right? And that variable can be either numerical or categorical, right? And so what we do with all the other variables, because we're not just going to collect information on one thing, right? We're going to collect more information. And the reason we do that is we're trying to explain changes in the response variable, okay? So explanatory variables are all variables that are not the response variable. So the nice thing about that is once you've figured out which variable is your response variable, then all the other ones are going to be explanatory variables, right? And explanatory variables are collected. Explanatory variables are collected to try to explain changes in the response variable. Okay, so explanatory variables are collected to try to explain, right? And that's why you have this explanatory explain, right? Changes in the response variable. Okay. Of course, this is statistics. Where would we be if there weren't a billion ways to say the same thing, right? And so a response variable can also sometimes be called the dependent variable. And I know because this is kind of a biology stats as well, I'm pretty sure in biology they prefer the terms dependent and independent variables, right? So if you're reading kind of a biostats textbook, it's very likely that they don't use the term response variable, but rather the dependent variable. Okay, so just remember that here. And then the explanatory variable can be called the independent variable, right? And kind of the same reasoning, right? The dependent variable depends on changes in the independent variable, but the independent variable just does whatever it wants, right? So especially if you're in biology, maybe keep an eye out for that. I like response and explanatory because I find that they're more descriptive of what they're doing, right? But let's see here. So the key is if we have some sort of research question, we need to be able to read it and identify which is the response variable, and then what would our explanatory variables be, as well as being able to say, oh, it's a numerical response variable. That's most likely, right? That we're going to have a numerical response variable because numbers are just more fun to deal with, right? We could have a categorical response variable, and depending on which we have, right, that's going to dictate our analyses. Okay, so for example, if we have the research question, what is the mean departure delay for flights departing from New York City, right? And so that's referring to that data set that we introduced last day, right? And so then we have a list of variables And we're going to classify each of these, right, as first either a response variable or an explanatory variable, and then as either a numerical variable or a categorical variable. Okay. So if we're interested in the mean, and just as a reminder, right, the mean is the average, which we talked about last day, right? It's really important that we keep on top of that terminology, right? We can use them interchangeably. So the mean, the average departure delay, right, means that the departure delay is the response variable, right? So this is the variable of interest. So the response is the departure delay, which I think is coded as dep underscore delay. Okay. So that's the first variable here. And so once we've identified our response variable, right, then all of these other variables are going to be explanatory variables. So that's easy enough. So let's start there. Departure delay, that's our response variable, which means that the arrival time, right, is an explanatory variable, right? Does the arrival time help explain changes in the departure delay? Maybe it does, maybe it doesn't, right? The scheduled arrival time, maybe that impacts the departure delay, maybe, maybe not, right? The arrival delay, maybe, maybe not. The carrier, the flight, you can kind of guess your way to which ones are potentially making changes in the departure delay or affecting changes in the departure delay, right? But once you identify your response variable, then all the other ones are just explanatory variables. So just start there. So this is an explanatory. And I'm going to cheat because I can. I should have written it a little bit nicer. Hey, maybe I can't. Paste. Paste. What's faster, just writing it out or cheating? Probably just writing it out. Pretty typical of me, right? And so, yeah, cheating, of course, is way faster. Yeah, I like to cheat. Copy, paste. In our shared office, I don't know if you guys know Stephen Brown, but we call it a bowl of copy pasta. Copy pasta, copy paste. So anyways, so in my mind, I'm going copy pasta, copy pasta, copy pasta. Thanks. Okay, so once we have that under control, right, then we need to identify each of these as either numerical or categorical. And if we want to really show off, which we do, right, we like cheating and we like showing off, right? And so then we might say a numerical discrete variable or a numerical continuous variable, right? And same thing for categorical. We might say a categorical ordinal variable, okay, or a categorical nominal variable, right? And so we really want to show that we know all this terminology and that we know how to use it. Side note, if you say ordinal, we know it's categorical, right? So I'm just kind of emphasizing, but I think you get the idea. So the departure delay is a measurement, right? So we definitely know it's numerical. Okay. But is it continuous or is it discrete? Here's where it gets a little bit tricky, right? You could argue either way, right? Because it's time, the departure delay is at time. So we could potentially measure it down to, some sort of microsecond, right? So let's say it's continuous. We'll argue that it's on a continuous scale. Right. I'll put a little asterisk here. We will argue that time is on a continuous scale, right? We're not just living every second, right? It's on a continuous scale, so I'm going to argue that time is on a continuous scale. There. Okay. Which makes things easier for things like the arrival time, right? We've already argued that, okay, well, if it's time, then it's going to be numerical and it's going to be continuous, right? The scheduled arrival time, same thing. Arrival delay is also a time measurement, right? It's a difference in the time, but let's call it numerical anyways. It is. The only two that are not numerical, right? Numerical continuous time variables are the carrier and the flight number, right? So which airline is it and what's the flight number? So all of these time variables, or the difference in time, we're going to call numerical continuous variables. So do I cheat again? I think so. Copy. Oh, I have to go outside the bounds. There. I should probably spend more time making sure the first one that I copy looks nicer instead of just. I think you get the idea. So we decided that the airline and the flight number, these are categorical variables, right? So let's start there. Categorical and categorical. And in terms of the airline, right, the carrier is the airline code. I'm pretty sure I didn't bring in the data set, but that's okay. If it's the airline code, we could sort them alphabetically, but it doesn't really give us any information. And so I'm just going to say that there's no natural ordering, right, besides sorting them alphabetically. But it's not like we're able to talk about, the largest one to the smallest one or something like that. So I'm going to go for no natural ordering, right? But if you argued that you should be listing them alphabetically, you could argue that you do have natural ordering, right? It's just depends on what you argue most of the time. And that's what makes stats so hard, because it's just about how you argue it. And then the flight number, again, we could sort it, but it doesn't really give us any information. So again, I'm going to go for nominal because there's no natural ordering. Okay. Good. All right. If we have, let's just grab all of this. Hey, I already wrote this. It's like I wrote these notes. It's what I usually say. I did write these notes. Oops. Okay. So in your lifetime, you've probably seen a graph like this. This is called a scatter plot, okay? And we map one variable against the other, right? So we've got an x-axis, and I'll do it in a different color so it's more obvious, right? So here's your x-axis, and here's your y-axis, and we're all coming from kind of varying levels of math backgrounds, right? So whatever you need to do to remember that this here is your x-axis and the one that's going up is your y-axis, you have to remember that, right? I had one student a long time ago, and she said, oh, I can never remember. So I had to figure out a way to remember that this was the x-axis. If you remember one, you can remember the other one, right? And so what she said was she just imagined that there was like a tree here. I'll make it a real tree. And then it was falling. And some little guy down here was like, no. And that's the x-axis. And I think that's like the cutest way to remember that that's the x-axis, if you have a hard time remembering, right? And so whatever you need to do to remember which one is which, it is really cute. I think, so that's why I love using that one, because it's like, oh. But also another thing that it helps with is that the x-axis, the explanatory variable, is always mapped on the x-axis, right? And so it's like multi-purpose here with this. And you know what? I'm pretty proud of this drawing today. So there's that too. The explanatory variable is always mapped on the x-axis, right? Which means what? It means that the response variable, the one that we're interested in, is going to be on the y-axis, right? But again, thank you. So then, but if you remember where one goes, you know where the other one goes, right? And so we're going to find that a lot, actually. Knowing one means that we know the other one as well in this course. And so this is where the response variable goes on the y-axis. How can I sneak a y into the response? Responsey? I don't know. Okay. And so here, later, and not for, I think, not until the end of the course, we're going to come back to these scatter plots, but it's good to have seen them and know how we map them, right? And it's probably the most fun section of the course, so I like to end there, is when we start modeling this relationship with straight lines, right? And so, because we can see that there is potentially some sort of trend here. It's a little bit wishy-washy, right? But we've got the departure delay, which was our response variable. And here in this case, we're talking about it against the arrival delay, right? Another explanatory variable. Okay. And so, of course, each plane is going to have its own, or each flight is going to have its own dot, right? Some arrival delay and some departure delay, right? That we map on a grid. Okay, so we'll come back to scatter plots later in the course, but it's nice to have seen them. Okay. I've said it once, I'll say it again, right? Everything that we do, right? We have to decide what's going to be appropriate, what analyses are going to be appropriate. And that's going to depend on if we have a numerical variable or a categorical variable. And then that's going to send us down the path, right? And so And what you'll notice is that the chapters are split up, right? I think we first talk about categorical data, right? And categorical analyses, and then we talk about numerical, or the other way around. We'll see. I can't remember how they changed it up, but anyways, so it's going to be really, really important that we can identify these. So my hope is that right now it's feeling really easy, right? Because that's where I want you to be, right? All right. So before we can analyze any data, we need to collect data, right? We're just going to talk a little bit about data collection. It's kind of its own field of statistics, sampling and data collection, and just how do we do it properly. So most of the time we're going to end up just using existing data, right? Data that's been collected by someone else, and then we just practice our analyses with that. But if you find yourself having to do data collection, then probably hire someone who knows what they're doing, and then you can blame them if it goes wrong, right? So multi-purpose. So a lot of data, and it's split up across the page, but I'll bring it in here. If you have to collect your own, hey, wrong file. Okay. Why did it print so weird? I don't know. It's my fault. I wasn't paying any attention, I guess. And I've used these for a long time now, so I guess I never care after class. I probably only complain in class, and then so we know that a lot of data exists already, right? Businesses are collecting data. There's a lot of publicly available data. StatsCan, Statistics Canada, cool kids call it StatsCan. They put out a ton of data that you can download and you can use and you can look at. And so there is a lot of data out there already. There's really rarely any reason for you to collect new data, right? But if you do, then we have to make sure. So if you have to collect your own data, you have to make sure that your sample is randomly selected, right? And so by definition, a sample is randomly selected if every individual in the population has the same probability of being selected, right? And hopefully when you read that, you think, well, that's not going to happen. And that's true, right? Because it depends on how you're reaching people, right? If you're using landlines to contact people, I don't know about you guys, but I don't have a landline anymore because I'm old, but I'm not that old, right? We're a cell phone only household. And so especially if you're working at a market research firm, right, those are decisions that you need to make. Buying cell phone numbers is really expensive, right? And so, but you can, and you know, they do. But another thing that you could do is if you're trying to just call numbers, right? And assuming you can even reach people by phone, that's another can of worms, right? So you can see how kind of hard it is to have a truly random sample, right? When we remember that each individual in the population has to have the same probability of being selected into the sample, right? So that's really, really hard to do. Okay. Oh yeah, another thing you can do, and the reason that you probably get a lot of phone calls from numbers that have the same 6 digits as your phone number is because they use a random digit dialer. So they just take, so my phone number, right, starts with 250864. So usually if I get a phone number from 250864, it's from a random digit dialer, an RDD. And so what they do is they just randomly generate other phone numbers, right? And then they pretend to be calling from that, but then that's how they reach me, is because they're on the 250864 stream, and then 8386, well, that's my number, so that's how they got me, and they randomly generated those 4 numbers, right? And so yeah, whenever I see a phone number from basically my phone number, well, I don't answer anyways, I don't pick up my phone, but then I definitely don't answer. So anyways, but that's how they do it, right? They just take the core chunk, and then they have to randomly generate just 4 digits. That's easy. And then they call those oh yeah, so it does need to apply. So the thing about randomly selected samples is we're always aiming to have a sample that's as random as we can possibly get it. So what we have to understand is that we're always facing challenges, right? It's hard to reach cell phone only households. There are some households that don't have any cell phones, right? They only have a landline. And so there's always going to be some portion of the population that we're not reaching. But we have to always do our best to try to have a random sample. And we're going to talk about some other sampling techniques as well. But I think that answers the question, maybe. There are some non-random sampling techniques, but for this course, what I want you to remember is that your sample should be randomly selected. The reason for that is because the goal of using this sample is to be able to talk about the population that it came from, right? And so the only way that we can do that is if the sample is truly representative of the population. And despite what you may think, you might think, oh, okay, well, the population in general is about 50% female, 50% male, right? Roughly. And so what you might head into your sampling thinking is, okay, I'm going to make sure that I have the same number of females and the same number of males. But we shouldn't do that, right? We should collect a random sample, and with the good random sampling, that demographic is going to evolve just on its own through random sampling. Okay, and so in order for our sample to be representative of the population, right, our sample must be randomly selected. Okay, and here it is important. What's important? It's important for our sample to be representative of the population, right? In order to have reliable statements, reliable information come out of it, right? So it's important for our sample to be representative of the population in order to have reliable results or analyses. Okay, so that's the important part, right? Is that our sample has to mimic the population for us to get reliable results or analyses, right? Remembering that core goal of statistics in general is that we take sample information to learn about the population, right? And so that's going to be really, really important. Okay. We're not going to talk a whole ton about here. Cut it off here. About sampling. Like I said, if you find yourself having to do any sampling, you should probably just hire a market research firm, and then they can do that for you. Okay. But in terms of sampling, right? Sampling is data collection, usually through surveys, right? If you're collecting data and you're sampling, then usually you're putting out some sort of survey, right? Whether it be an actual survey where you answer questions, or it could just be something where you just observe data, right? But in general, if we're collecting information from other people and we're getting them to answer questions, then what we need to do if we're reporting those results, right, it's really important that we report the response rate. Okay, so the response rate is the number of the responses divided by the number in the original mail out. Now, I use mail out as kind of a general term, right? I guess I should have kind of air quotes about the mail out. The mail out is just a general term for all the people that you tried to reach, right? Whether that be a call or actually through the mail, right? So the number of people that you tried to get to answer your survey is the number in the original mail out, okay? And so the number of responses that you actually got divided by the number in the original mail out. Now, usually this is where people ask me, well, what's a good response rate? And the answer is, it depends. It depends on how difficult the population that you're trying to reach is, right? Sometimes maybe even 10% is really good, right? You might be dancing on the table with 10%. And sometimes if you have a really easy to reach population, 10% is really, really bad, right? And so it totally depends on who you're trying to reach. And also the response rate, right? If you have responses from 200 people and you only tried to reach 250 people, that's a big deal, right? You were able to get responses from a lot of the people you tried to get responses from, right? Whereas if you tried to reach 10,000 people, but you only got 200 responses, right? Now, all of a sudden, this sample size of 200, right? Because that would be your sample size, the people you actually got information from, right? So we have the same sample size, but now all of a sudden 200 is not very good at all, right? And so it's really important that you report the response rate just because, again, right, a low response rate indicates that we have less reliable results. Why is that? Well, if we have a low response rate, right, we tried to reach 10,000 people, but we only got information from 200, it's very likely that these 200 are not representative of the population that we tried to reach, right? We tried to reach 10,000 people to make sure that it's representative. And you always oversample, right? You always go for way more than you're actually hoping to get, right? But that's why it's so important to report the response rate, is because a low response rate indicates that we have less reliable results, right? And less reliable in the sense that the sample is not representative let me try that again. Representative of the population, right? So that's always going to be the case. As soon as your sample is not necessarily representative of the population, all of a sudden you have less reliable results, right? That's bad. Okay. And here I keep it nice and vague, right? We need a reasonably high response rate to draw reliable conclusions about the population using our data. And this is where it depends on, the industry that you're in, right? If you're in biology, you're probably doing more experiments, right? But maybe not, maybe you're doing surveys. And then you have kind of more control over your response rate. But if you're in the social sciences, then maybe a lower response rate is to be expected. It just depends on the field that you're in. So that's why I'm keeping it nice and vague and not committing to anything, right? That's how we do it in statistics, right? Say a lot and nothing at all. So first thing I want to do is just highlight what some bad sampling is, right? Things to avoid or try to avoid. Like we already kind of talked about, sometimes it's hard to avoid these things, right? Bad sampling, non-random sampling. But then I want to talk about just some good sampling techniques that we can use just in general. Okay. So bad sampling is, and I'm going to try to bring in this whole kit and caboodle here. Whoa. Okay. So bad sampling is any sampling that's biased. Now, of course, we have to think about the definition of bias. But biased is probably a word that you've used, in life, potentially, maybe not, I don't know. So we have an idea of what it means, right? But bias, by definition, is systematically favoring one outcome, right? And so that would be bias, right? Where we're trying to get a certain outcome. That's not what we want to do, right? And so there are a couple of examples here, but I'll highlight the definition here, right? Things to avoid would be voluntary samples, right? So if you are on a website, right, and it says, hey, would you mind doing this survey after you finish? That's voluntary sampling, right? Because you have the option of saying yes or no. And you're really only going to hear from people who care strongly one way or another, right? And so that would be voluntary samples. And although we use them, right, we have to acknowledge that the results are maybe less reliable than they would have been if it was actually randomly sampled, right? So we can use them, we shouldn't ideally, but sometimes we have to. And if we have to, then we have to acknowledge that our results might be less reliable, right? So another kind of bad sampling technique is convenience samples, right? So for example, if you're at the college and you're trying to collect information and your population of interest is all college students, right? Even right now, most of the college is online, or at least half, I think. A lot of the college is still online. Some are back to face-to-face, right? So if you just went to the campus and tried to get people to answer your survey, right, you're not actually getting a very representative sample, right? You're getting students who are back face-to-face with their classes, and they might be taking specific classes, right? And that might make them kind of a subset of the population that you're interested in, right? And so convenience samples work like that, where you just, you might not have enough money to sample everyone at the college, right? Or take a random sample, that kind of thing. So it's usually money-based, right? That's why we do convenience sampling. We shouldn't, but that's usually why people do it. Okay. Some other things to avoid, and then I say / be aware of, right? Because sometimes they're unavoidable, right? Sometimes it's just a thing that we need to add into our report and just kind of say, oh, and by the way, we had undercoverage. Undercoverage is where maybe there's a certain demographic that you meant to have in your sample, but you couldn't get to because they wouldn't answer your survey, right? Maybe there's a non-response, right? Maybe people are just not filling in the survey in general, right? Maybe you have a low response rate. Maybe you have response bias. That's something to look out for, right? If you're creating a survey, then you want to avoid response bias. And things to keep in mind there are the wording of questions and even the question order. Oh, where did I? Okay, now I've hidden it from myself, but I got this. So of course it's the elections, and I voted yesterday. And so I got this survey in the mail and it was so biased, it was insane. So I kept it, but then now I don't know where I've hidden it. So I'll try to find it for next day. But the wording of the question was really weird, right? And so I wanted to show you that that would be bad sampling, right? And the people who would answer that survey feel a certain way, and that's where they're getting their information from, but also the question order. And I have some, I think, really interesting examples of how important these things are, okay? And so I just want to read through these examples. Wow, it's like, a survey was trying to figure out, how do Americans feel about illegal immigrants? And so one of the questions was, should illegal immigrants be prosecuted and deported for being in the US illegally, or shouldn't they? That's a weird question to ask, right? That's a multi-part question in one, so bad, right? Asked this question in an opinion poll, 69% favored deportation, okay? But when the very same sample, and that's the kicker, right? So, but when the very same sample, so the exact same people, was asked whether illegal immigrants who have worked in the United States for 2 years should be given a chance to keep their jobs and eventually apply for legal status, right? 62% of the same people said that they should. That's kind of the same question, right? But the wording of the question is so different that there's overlap there, right? So 69% said, oh yeah, they should be deported, right? But then 62%, so now we're talking about quite a bit of overlap here, said that, yeah, they should be able to just keep their jobs and stay, and that's fine, right? And so different questions, right, give us different impressions of the attitudes, right? And definitely political parties use this to their advantage depending on what their stance is, right? And so that's why it's really important to try to avoid this type of question bias, right? Same thing, right? And of course, these are all kind of sticky subjects, right? But that's usually what we're collecting information about, usually, right? So government help for the poor, only 13% think that we're spending too much on assistance to the poor, but 44% think that we're spending too much on welfare, right? But assistance to the poor is welfare, right? These are the same thing, but depending on what word you use, you're going to get drastically different values here, right? And so that's just something to remember if you're collecting information, if you're in charge of collecting information, right? Now let's talk about good sampling. What should we be doing, right? So we should be avoiding bias as much as possible, right? And bias comes in many forms, but good sampling split up across the page, but good sampling, like we established, is good. Copy this whole thing in. Gonna put this down here. Good sampling is a randomly selected sample. Okay. How do we collect a random sample? There are lots of ways, and you can get creative with it, right? The easiest way to collect a truly random sample is a simple random sample, which is exactly what you think it is. You have your entire population, ideally, right? And then you randomly select a sample of some size from that population. That's easier said than done, right? But if you imagine you're trying to take a random sample of all the students at the college, you could do that, right? Because the registrar has all student numbers, right? And so what you could do is you could randomly generate a number, right? So you could number each student in there. And why wouldn't we use their student number? Because I don't know if your student number has information like how long you've been at the college, right? Which would probably mean that you're older than the other groups, right? And so I don't know if there's other information in your student number, right? Your 300 number. I don't know. So I want to avoid using the student numbers themselves. So instead, I'm going to assign a number to each student, right? Maybe 1, 2, 3, blah, 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 up to, I don't know how many students we have, but everyone would get a new number, right? And how I assign those numbers is not important, right? But how I pick the numbers that are going to be in my sample, that's important. So I could do something old school, like I could put all those numbers like a raffle in a hat, and then I could randomly pick numbers. Number 48, you're in my sample. Number 157, you're in my sample, right? And so on and so forth. More commonly, what we would do is you probably have all the students in your spreadsheet, right? An Excel spreadsheet, typically, this is how I would do it. Right, you've got some sort of spreadsheet, and then I like to use random.org because there are random number generators in Excel that are built in, but they're not truly random if you want to get picky about it, right? Because we still have to program these computers to generate random numbers. And so random.org claims to have the most random number generator there is. So then I generate the sample size that I want. So 100, if I want a sample size of 100, I might generate 100 random numbers in the range that I have. And then everyone that's on that list is in my sample, right? That's one way I could do it. That would be simple random sampling. Okay? And usually we use the term SRS. That's going to come up quite often. And so it's just a basic random sampling technique, right? Just you have your whole population and you're randomly selecting people from that population, or animals or whatever. So there are more sophisticated techniques, right? We're only going to talk about 3 more. There are others, of course. People are always trying to get creative, right? But these are the core few. So a stratified random sample is when the population is divided into groups that we call strata, right? And so there's a little footnote here that says the strata are chosen so that similar cases are grouped together, right? So for example, strata might be at the college, it could be the program that you're in, right? Each program would be its own strata, right? In terms of Kelowna, right, the area that you live in might be its own strata, right? And then you randomly select a sample of the same size from each strata, right? So maybe you're randomly selecting 20 people from the science program, right? Maybe you're selecting a random sample of 20 people from, well, maybe science was a little too vague, maybe from math, computer science, right? Engineering, mechanical engineering. It depends on how you define your strata, right? And so you randomly sample a set sample size from each strata, right? Here's where it gets a little bit tricky to remember, right? But a cluster sample, right? The population is divided into many groups, right? So those groups are called clusters. Why we don't call them strata, I'm not 100% sure, but we call them clusters. And then what we do is we randomly sample a fixed number of clusters, okay? And then we include all the observations from each of those clusters, right? So we separate, it's easier to talk about the college, right? So we separate everyone into their own program, right? Assuming that you're in some sort of program, declared program. And then we randomly select maybe 10 of those programs. And then everyone in those programs that were selected would be part of our sample. That's cluster sampling. Okay. And then multi-stage sampling is if you want to take it one step further, right? You have a cluster sample, right? So you're taking, you're splitting your population into clusters, right? And then you're randomly selecting some number of clusters. And then instead of looking at everyone inside those clusters, you would take a random sample within those clusters, okay? This is not something that I expect you to memorize, maybe, but I do expect you to be able to identify it, right? If I give you some example of how this data was collected, then you should be able to tell me that, oh, that looks like cluster sampling, or that looks like a stratified random sample, right? And so we need to kind of be aware of these sampling techniques. Okay. Good. Mm-hmm. Oh yeah, what's the key difference between stratified and cluster sampling? So for stratified random sampling, right, we've got our strata, or we can call them clusters, right? So we've broken our population into groups, right? So now we have groups in both situations. But stratified sampling is when we randomly sample some number from each of these groups, right? We might take a random sample of 10 people from each group, right? To make sure that we have the same number from each group. Whereas cluster sampling is, so we've broken up our population into some set number of groups again. Oh, I think Strata has, you could break it up further if you wanted to, but we're not going to go that far. No. So then cluster sampling, you still have those potentially same groups, right? But now you're randomly selecting only a few of those groups and looking at everyone in those groups, right? So a little bit tricky and might take some time, but like I said, it's not something that I expect you to memorize. It's something that I expect you to be able to identify, assuming that you have these definitions available, right? So you should be able to read an example of a study and tell me how they selected their data, right? Okay. I think hopefully that answered it. All right. So in general, in cluster sampling, exactly. So in cluster sampling, we're sampling the random clusters, whereas in stratified sampling, we're taking samples from every cluster, right? Randomly sampling from every cluster. Good. You got it. So there are two ways of collecting data, right? And we're familiar with both, right? Definitely experiments, right? You've heard of experiments. You're probably thinking, you know, some lab coat with some glasses and, you know, you're doing experiments, and that's exactly what it is. Observational studies are everything else, right? If we're just observing information and we're not controlling anything, so things like surveys, when we collect market data, when we collect data off the internet, right? Those are all observational studies, right? It's not until we're controlling for certain factors that we have an experiment. So first, I want to talk a little bit about observational studies, and then I'll try to get to experiments because these are just pretty basic ideas, but and then I'll be a hero today. So in observational studies, data are collected just by monitoring, right, or observing what happens. So surveys and user data and kind of market research data, everything that we do where we just collect information, right, are some common ways of collecting observational data. So observational studies, we can break them up into two forms. I don't really refer to them as this, but it's good to have under our belts. We can talk about prospective studies, right? So prospective studies, if you think about the word, is kind of forward looking, right? So you identify individuals and you collect information as events unfold. Things like potentially drug trials, right? You might call it an experiment because some people are getting the drug and some people are getting a placebo. But in general, we could call that a prospective study, right? Things like, what's an example? I want to say the census, but that goes out to everyone. Anyways, where you have a group of people and you're just following them to see what happens. Okay. Oh yeah, I think there's like pregnancy ones, right? If you recently became pregnant, then you might be asked to enroll in this study and you just report what's happening, right? Even COVID studies, right? You had a group of people, maybe they're volunteering and they're saying, yeah, I'll commit to giving you information for the next, 3 months or whatever about how I'm feeling or whatever. But those would all be prospective studies because they're looking forward. Retrospective studies are looking backwards, right? So a lot of these definitions are just in the word. Pro is forward, spective is looking, and then retrospective. Retro is backwards, spective is looking, so looking backwards. So retrospective studies collects data after events have taken place, right? And so usually that's probably what we're going to be doing, right? Is just looking at data that has already happened, and we just want to analyze that. Okay. For experiments, now I will say that experimental design, especially if you're in the biology track of this course, right? Experiments and experimental design are its own field of statistics, right? Because there's so many things that you can do. But for us, we're just going to talk about kind of the key points. We're not going to dive into it too much. The textbook goes through it a little bit if you're interested, but we'll leave it for a second course in statistics. Don't you love it when textbooks say that? We leave that for a second course. So an experiment is when we can control all the factors that might affect the response variable. Okay, so I'm going to highlight that because that's the most important part. Okay, if we're able to control all the factors, all the things that might affect the response variable, right? That's the only way that we can establish a causal relationship. A causal relationship is when we're able to say something like increasing the amount of sun a plant gets causes a change in its growth, right? So if you're able to control everything in the environment, everything, that's the only time that you can establish a causal relationship. Okay. Right, so things like A causes a change in B. The only way that you can say something like that is through an experiment, right? And it has to be a really, really, really controlled experiment where you're able to control everything. That's really hard to do, right? Which makes this statement really, really hard to say, right? So we should never say that, okay? So if you're doing an experiment, especially a medical experiment, that's kind of the most common one that we're talking about here, especially if it involves human subjects, right? You want to make sure that you have a blind study. Now, a blind study, just regular blind study, is when the subject does not know whether they're receiving the treatment or the placebo. Okay, so in that case, you would have maybe a nurse who says, take this pill, and you don't know what pill it is, right? Ideally, you would have a double-blind study. Now, a double-blind study is where the nurse also doesn't know what she's giving, right? And the benefit of that is she might be, or they, I should say, they might be treating the subject differently if they know that they're giving the treatment or the placebo, right? And I've got it here, but a placebo, hopefully you are aware, but a placebo is a fake version of the treatment, like a sugar pill, right? And usually we have the placebo group as a control group. Okay. So the placebo group, is the control group. Okay. What happens surprisingly often is that people have the placebo effect, right? Where they think they're getting this treatment and they feel like they're getting better, and maybe they do get better, right? Just from believing that they have the treatment. And so that's another thing that you have to deal with experiments. But ideally, you have a double-blind study, right? where the person who's giving the treatment also does not know what treatment they're giving. And the subject, of course, doesn't know what treatment they're getting. So that's what makes it double blind. Okay. All right. So that's the end of chapter 1. I know I called it chapter 1, part 1, but I'm going to stick to the textbook for next day. So that's good. So we'll call it chapter 2 next day. Any questions? If you do not have any questions, I will see you on Thursday. I'll stop this recording.